virtual MOSI. This is Engineering Week. My name is Catherine, and what we're going to be doing today is building our own batteries. Now, do you have any devices that contain batteries? Maybe your cell phone, or a laptop, or a drone, some cool toy? Batteries are super important, right? What do you think the world would look like if all of our electronic devices had to be plugged into a wall? Well, luckily we don't have to wonder because we have batteries. Now to some people, they might not be so clear on how batteries work, but all they are is a device that transmits chemical energy into electrical energy. And we're gonna make our battery today out of something really, really simple, pennies. So our battery at the end is gonna look something like this. I wanna show you how it works. And I have these little LED lights. And those are just some pennies and some cardboard between them, and our LED is lighting up. I hope you can see that okay on the camera. Perfect. All right, so how are we gonna make our battery? First things first, you're gonna need some pennies. I suggest at least 5 or 6. You're gonna need some sandpaper, some water, some salt, a little bit of vinegar, some cardboard, and maybe the hardest part to find is gonna be LEDs. Now, if you have these at home, great. If you don't, they are very inexpensive. That's the benefit of LEDs, light emitting diodes. So hopefully you can find some of those at a craft store or a tech store, I guess, or even online. This whole box only cost me $1 or $2. Okay, so the first thing you need to do is find pennies that are younger, I should say, pennies young and old, that are more recent than 1982. Now, pennies used to be made completely out of copper, but believe it or not, it started to cost more to make pennies out of copper than pennies are worth, 1 cent. So what we did is we tried to make it more cost effective, and we made our pennies out of another metal called zinc, and then we coat them in copper. So if you look on the inside of the penny, they look something like this. They're completely made of zinc on the inside, and the outside is copper. And that's going to be to our advantage today. So what you need to do is shave off one side of your penny. And to do this, protect my finger a little bit and keep it attached, I use duct tape. I get my penny, there we go, and I start to rub it along the sandpaper. Okay. And after a while, all of the copper will be gone and you'll be left with zinc. Pretty cool, right? So you need to do that for at least 5 pennies and put them to the side. Make sure that you leave 1 penny unshaved, completely normal. You need copper on both sides of one of your pennies. Okay, next step. Fill a cup with some water and pour in a lot of salt. And when I say a lot, I mean a lot. You want to add so much salt that it stops dissolving into the water, because the salt is going to act as something called an electrolyte, a very important part of our battery. Okay, I'm even going to add a little more. Don't be shy there. Keep going. Now, one of the things I'm going to add is just a little bit of vinegar. It doesn't matter what kind. I'm using white vinegar. You only need a very, very little bit, because it is going to act as what's called a catalyst in our reaction. It's going to help speed it up a little bit. Okay. Not crucial to the reaction itself, but this is going to help things move right along faster and faster. Okay. The next thing you need to do is get some cardboard. You're going to want to cut out pieces of cardboard, or very thick paper, cardstock maybe if you have it, that are a little bit smaller than your penny. So if you have 5 pennies, you're going to need 4 pieces of cardboard. Let's just throw a few of those in there. Maybe an extra just in case I need it. And you're going to need to wait for them to soak up all of that salt water as much as possible. Any questions so far? Feel free to put them in the comments. I already let some of my cardboard soak, so they are good to go already for us. And this is how it's going to work. We are going to make something called a voltic pile. We are going to add our pennies in sequence right on top of one another to kind of build up the electricity. One penny alone could produce perhaps half a volt of electricity, and we need a little bit more than that. So, easy solution. We are going to take pennies and stack them together. You want to take the copper side, see I have a silvery zinc side and an orangey copper side, and you want to put the copper side down on the table. Easy peasy. Make sure that your pennies are somewhat dry. If they're too wet, this might not work right away. You might have to wait a little bit for it to dry. Okay. So again, your cardboard should be a little bit smaller than your penny because you don't want the different cardboard pieces to touch each other. Put the cardboard on top of the penny and keep stacking. Make sure you keep stacking them in the same direction or this won't work. So copper down, zinc up, cardboard, copper down, zinc up, some more cardboard, copper down, zinc up, and then finally, oh, I've got another penny here. Might as well put it in. Okay. Copper down, zinc up. And finally, the last step, remember I said you need a complete normal penny. So, after we put our cardboard on this last one, we have a normal penny that we are going to put on top. Okay. Hopefully that'll work and it's not too wet right away. Now we need to find a way to connect the bottom of our penny to the top of our penny, our little battery here. So I've got my little red LED here. It has two legs, one's a little long, one's a little short, and I'm going to put them on top. Okay. Now if it doesn't work, for some reason, you might have your LED in the wrong direction, which I've tried it both ways, and I think our battery is a little too wet here, so I'm going to rearrange. While I rearrange my battery, I want to talk to you about a couple steps that you can look at if your penny doesn't work right away.
May I ask a question?
Yes,
we have a question from the audience.
Please.
And the question comes from Ermilo. Why did you soak the cardboard in salt water?
Well, we soaked the cardboard in the salt water so that it would absorb as much salt water as possible. And we're going to talk about why that's important when we go over all the steps of how our battery is working. So let's see. I think my cardboard might have been a little too wet, so that's something to consider. Is your cardboard too wet? Did you use enough salt in your solution if your battery is not working, for instance? Make sure that all of them are pointing in the right direction, and make sure that you have a normal penny on top. Also, if your cardboard is too dry, that might be a thing too. So too wet isn't good, too dry isn't good. Need kind of a happy balance there. Okay, let's see if we can get that to work a little better. And if not, I'll let it dry while we talk about how the battery works. Okay. All right. So we'll come back to that in just a second. You saw it was working earlier. So it's just a matter of getting the right level of wetness there. Let's talk about how our battery is working. We were wondering why we needed to soak the cardboard in salt water. So let me direct your attention to this image right here. When we make a battery, the first thing we did is we dissolved salt into water. Now salt is just, its chemical formula is sodium chloride. Those are the atoms that make up salt. And salt is an electrolyte. It's something that when we dissolve it in our solution, in our water, it conducts electricity. Salt water conducts electricity. So far, so good? Excellent. And remember, we have two types of metals. We have zinc on one side of the penny, and we have copper on the other side of the penny. Now, when the metals interact with the salt water, a reaction forms, a chemical reaction. And in the case of zinc, the chemical reaction that occurs is called an oxidation reaction. It gives off extra electrons. But in the case of the copper, the chemical reaction that occurs when the copper touches the salt water is a reduction reaction. It takes extra electrons. So we have two reactions occurring. One that's producing extra electrons and one that needs extra electrons. By putting between them on this side, but putting a wire to connect the two on this side, we've given the electrons a path to flow from one metal to the other. And when the electrons flow through our wire, we can make them do work, such as putting on a light bulb. The cardboard is an important permeable barrier because it prevents the battery from shorting out. Now, the sodium chloride, that salt, in the electrolyte solution is broken down into sodium ions and chlorine ions. Remember, ions are just atoms that either have too few or too many electrons. Electricity is just the flow of positive or negative charged particles, and we're using this chemical reaction to produce electrical energy. So that's really, really cool. Remember, electricity is never created or destroyed. It has to come from somewhere.
I have another question.
Yes.
This comes from Brian. Does the kind of salt make any difference? We cook with sea salt. For your battery, does it matter the type of salt that you're using?
It shouldn't, because it's all the same atoms that make it up. The difference between sea salt and regular salt is mostly particle size. And no matter where salt comes from, it's all the same chemical. Okay. So, one issue too that you might have with your battery is you might not have stacked enough voltage to get your light to go up. So let's see if I can fix that again. I will use the one that I know worked pretty well. Let's use this one. That's the one we did together. And pardon me while I do this one more time. I really want it to work for you guys. And you'll notice that I have a lot of different colored LEDs here. I have red ones, blue ones, and green ones, and yellow ones. If you listen to our light lesson, you know that it takes different energy levels to make different colors of light. Different colors of light have different frequencies, right? Do you remember what kind of frequency red light had? Was it a low frequency or a high frequency? What about blue or purple light? Was that a low frequency or a high frequency? Well, red light is low. It has a low frequency, and blue light has a high frequency. So in theory, we need less energy to get our red LED light to light up than our blue LED to light up. What could we do to make our battery better and more likely to get the blue light to light up? Remember, I said each penny by itself produces about half a volt of electricity. So, I'm going to leave that up to you. I'm not going to answer that for you, but if you make this little experiment on your own, I hope you can guess what might be a good idea. Did we have any other questions?
Yes, we do. We actually have one question and one comment.
Yes.
The question is, for your experiment, does it have to be a LED that you use to try to light up?
Well, no, it doesn't have to be an LED. But LEDs are typically much easier because they require very little amounts of electricity. They're more energy efficient than, say, an incandescent light bulb. So if you were to try to do this with a regular light bulb, you would need to stack quite a lot of pennies.
Okay. And then the comment is, would a yellow LED work better than a red one? That comes from Jose.
Well, Now, I believe that yellow light is a higher frequency than red light, but we can test it out. Something changed from my initial battery to this one to make it less working. All right. And remember, I said that there's a chemical reaction that's taking place when we are changing our electrolyte solution with the metal into electricity. So eventually that's why eventually all batteries die, because eventually all that metal gets used up. Oop, there we go. All right, just needed a second to dry there. So be patient when you test it at home. There's a lot of variables that you might need to change, and you might need to be patient while some of that cardboard dries. A lot of things you can test. Let's see if we can get the blue one going now that the red is. Aha, it's very, very low. Let's test a green one, because that's kind of in the middle of red and blue. And remember to switch the legs if you can.
Oh,
nice. That was a good one. And you'll notice as I'm moving it, the light quality is changing. So I might have a little bit of a short going on with some of that cardboard. Let's test that yellow one again. Switch those legs up. There we go. Excellent. And actually even more difficult, I find, than the blue one to get to light up. So if you really want to challenge, is these white lights. Because remember, white light is made up of all the frequencies, all the colors of light that there are. So yes, in fact, I am not able to get the clear one to light up because it takes so much more energy. But the red one, just fine. And I wanted to say, let's turn off the light so you can see that a little better. Very nice. Okay, and you can also try perhaps lighting more lights on your battery at once. See if you can do that. And the more lights you add, the more energy it's going to take, remember. And rechargeable batteries are really cool too, because they allow that reaction to go in the opposite direction when you plug it into a wall, and kind of have those electrons flow in the other direction. Okay, very cool. Let's try that green again. I really was partial. Okay, nice. So yeah, all you need for this activity, guys, just some batteries. To make your own battery, just get some pennies, some salt water, and an LED light, some cardboard, and you should be good to go. I hope that this taught you a little bit more about a technology that you use every day, and I hope it gives you a chance to explore and experiment on your own. Thanks for joining us, and as always, keep discovering.